Scholar Strive doing some math today in Algebra 2. We're going to be looking at graphing the natural base. The E, Euler's number. So the parent function is y equals e to the x. And the general function is y equals a times e to the r times the quantity x minus h, and then plus k. So the the a value stretches, shrinks. R value, we'll get back to the r, but the h value shifts it left to right, and the k value shifts it up and down. Back to the r value, so if your a value is positive, and your r value is positive, then it's an exponential growth. If your a value is positive and your r value is negative, then it's an exponential decay. So let's go ahead and graph some of these. Number 1 here, y equals e to the negative 2x. So the first thing you should do is list out all your parts. So your a value in this case is 1. You don't see a value there, so it's 1. R is negative 2. H is not there, so 0, and k is not there, that's 0. And I like to use negative 1, 0, 1 for these. So there's really no, trick to these with calculating. You have to put it in your calculator. If you plug in negative 1 into your calculator, you'll get 7.39. And now this one you can do in your head. If you plug in 0, e to the 0th power, anything to the 0th power is 1. And if you plug in 1, you'll get 0.14. So when you go ahead and plot these, 0, 1, 7.39, so around here, and something pretty low. So you got your basic shape here, and this is a decay. One thing is because r is negative. 2, if you look at the graph, it's decreasing from left to right, and it has that exponential look to it. Part 2, or number 2, sorry. Let's do this. Oh wait, domain. So domain for all these e functions will be all real numbers, and your range is going to be dependent on whatever k is. So it's going to be y is greater than k, unless you get flipped over, and then it's y is less than k, just like we've been doing before. So let's do number 2. Okay, a value, 3, r, 1, h, 0, k, 0, negative 1, 0, 1. Plug it into your calculator, get 1.110, or 1.10, and then plug in 0, you get 3. E to the 0 is 1, times 3 is 3. 1 is 8.15. Domain still all real numbers, and that is still greater than 0 for the range. General form. Let's see here. Let's plot these. So up 3, make a dot. 1 is 8.15, so something up there. And then 1 is just a little bit over 1. So we got this going on. And once again, these graphs are approaching an asymptote. It approaches but never touches, and it's always y equals k, so in this case y equals 0. Alright, let's do a different one. Number 4. A is 1/2. R is 1. H is -3. So remember, once again, H is always the opposite of whatever it says, x plus 3. So H is -3. K is -2. Domain is all real numbers. Now this is where it changes. K is -2, so y is greater than -2. Oh, this was a growth. And this will also be a growth because R is positive, and so is A. So this is where I change it up a bit. I always like to use numbers around my H value. Normally I would do -4, -3, -2, but I'm going to do -3, -2, -1. Let's go ahead and punch these in. So if I punch in -3, that would be e to the 0. E to the 0 is 1, times 1/2 is 1/2. -2 is -1.5. And then we got -0.64. If we plug in -2, plug in -1, we get 1.69. And then if we look at this, let's draw in my asymptote at y equals -2. It's going to be, so -3 is around 1, 2, 3. So around here. -2 is next to 0. And -1 is 1.69. So around there. So whatever approaches, but never touches, and this goes up in a favor. Alright, number 6. A is 1. R is 2. H is -1. K is -2. So y is greater than -2. This is a growth. So -2, -1, 0. So -1.86, -1, 5.39. So once again, I use x values around my h. So -1, -1 down here. It's approaching this line. -2 is almost there, but never touching. And 0 is 5.39 up here. Alright, hopefully this helps you out on how to graph these. Basically, you're just graphing the same way, you're just plugging points into a calculator. Have a good day.